Think finding numbers that are even, perfect squares, and perfect cubes sounds complicated? Think again. By the end of this video, you will see just how simple it is. Trust me, you will stick and stay around because I've got a surprise waiting for you at the end that you won't see coming.
So today we are looking at special numbers. Right. Special numbers. And so let's take this question. Question 1 says calculate 1 squared. 1 squared. 1 squared is simply 1 times 1, and so 1 times 1 is 1. B says 5 cubed. 5 cubed is 5 raised to the power 3, and that is 5 times 5 times 5. The 5 times 5 is 25, times 5 is 125. 9 cubed. C says 9 squared. C says 9 squared, and 9 squared is 9 times 9. 9 times 9 is 81. D says 1 cubed. 1 times 1 times 1 is 1. And so we are done with question. So question 2 says, what is the sum of the third square number and the fifth square number? We are looking for a summation, that's an addition, of the third square number, that's 3 squared, and the fifth square number. So this is an addition to the fifth square number. So that's 5 times 2. And this is simply 3 times 3 plus 5 times 5. And 3 times 3 is 9 plus 5 times 5, 25. And so we have what? 34. So the answer is 34. Okay. Question 3 says, what is the difference between the 10th square number, the difference, so a subtraction of the 10th square number, the 10th square number, and the fourth square number. So the fourth square is 4 to the power 2, and that is 10 to the power 2 is 100, and 4 to the power 2 is 4 times 4, which is 16, and that is what? 84. So our answer is 84. Okay. Question 4, it says draw a ring around the expression that are equal to 6 squared. 6 squared is simply 6 times 6, not 6 times 2 and not 6 plus 6, but 6 times 6. It's also not 2 times 2 times 2 times 2 times 2. It's 6 squared, so 6 to the power 2, and that is 6 times 6. So this is it. It's not this either, and it's not this 2. Okay. Question 5. Annie and Heidi play a game of what's my number. Annie says, is the number less than 50? And Heidi says no. So the number we are looking for is not less than 50. Okay. Is the number more than 100? No. So the number is still not more than 100. Is the number a cube number? Yes. And the number is a cube number. So we are looking for a cube number. Let's make the number x, which is greater than 50 but less than 100. So x is our cube number. So let's start. What's a cube number in the first place? A cube number is a number that multiplies itself 3 times. So when we start from 1, okay, 1 times 1 times 1 is going to give us what? 1. So it doesn't fall in the range of our answer, so we ignore that. Let's go to 2. 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. Okay. Let's 8 also does not fall in the range of our answer, so we keep on going forward. 3 times 3 times 3, that is 9 times 3, and that is 27. 27 still does not fall in the range of our answer, so we move on to 4. 4 times 4 times 4, that is 4 times 4 is 16, times 4 is 64. Okay, this looks like it could be our answer. Okay, this looks like something that could be our answer, but let's try 5 because we want to be very sure if we are on track. 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. Now 125 is obviously more than 100, and so this is also not in the range of our answer. But what we are sure of is in the range of our answer is 64. And so the number Amy is thinking of is what? 64, because 64 is greater than 50, right? And it is also less than 100 as specified in the question. Question 6. Question 6. A number is squared. Let x be our number. Okay. A number is squared, so x is squared. And then 2 is added. And the answer is what? 6. What is the number? Now we are looking for what x is over here. So let's do away with anything around x. So we have x squared. In order to get rid of this 2, we subtract 2 from this part of the equation and we subtract 2 from here. So we have x squared plus 2 is equal to 6. We subtract 2 from here and we subtract 2 from here. Whatever you do to one side of the equal to sign, you do to the other side of the equal to sign. So now we have x squared plus 0, because 2 positive 2 minus 2 is 0, is equal to what? 4. Okay. And so now we have x squared is equal to 4. And we know that it is only two numbers that when we multiply, two similar numbers that when we multiply we get 4. And that is what? 2 times 2. 2 times 2 is 4. So therefore, our answer is 2. Our x is 2. Question 7. Question 7, we have a simple one here. A says 1 squared times 1, that is 1 times 1, because 1 squared is the same as 1, and that is 1. We have B, it says 5 times 5 squared, and 5 squared is 25. So 5 times 25 is what? 125. 3 times 3 squared. Okay, 3 times 3 squared, we have 3 squared to be 9. So 3 times 9 is 27. 4 squared times 4. 4 times 4 is 16. And 16 times 4 is what? 64. Okay, so question 8. It says Vincent makes a sequence using patterns of rectangular bricks. Draw the next pattern in the sequence. And so over here, what I study or what I see is that they start with one brick here, one brick here. Okay, and then the two parts I see two bricks laid in the center like this. So we have this brick. I will name this brick A, and then I'll name this brick B. Okay, so we have two bricks, right? And then the three position 3, I can see 3 bricks in the middle, and then they arrange on top as it goes, right? So I see A, I see B, I see C. Then what do we think, how we think the pattern for 4 would be? It will simply be a continuation. So it's going to be 4 bricks laid in the middle. I'm going to try my best to draw as clean as I can. Okay. Okay, so let's assume we have these 4 bricks. Beautiful. I'm not bad. Okay. And then they continue to draw what? 3 bricks. And then we continue to draw, we have 2 bricks. And then we have lastly 1 brick here. And then here too, if we continue to draw the same thing, we have 3, we have 2 bricks, and then we have the last one here. So we have 1. Let's count the bricks, please. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, 16. So we have 16 bricks here. Let me just put this down here. So 16 bricks. Okay, let's count the bricks for 3. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 bricks. And here we have 4 bricks. And here we have 1 brick. 1 brick. Okay. So well done. This is a good pattern. Let me use my red. Okay. Nice one. Okay. So B part says we have the shape. We have shape 1, 2, 3, 4, and 5. And so the number of bricks for 1 is 1, as you can see over here. Okay. 1 is 1. The number of bricks for shape 2 is 4. Number of bricks for shape 3 is 9, as we counted. So we put 9 here. Number of bricks for 4 or shape 4 is 16. Okay, so we put our 16 here. Okay, so after writing our 9 and our 16 number of bricks over here, if we notice or we analyze the sequence in order to find our number of bricks for position 5 or shape 5, it's going to simply be, I can tell you right away, but I want you to just analyze this. Okay, let me help you. So what I see going on here is nothing far from, the shape or the number of the shape being multiplied by itself. So 1 is being multiplied by itself to get a number of bricks 1. 2 is being multiplied by itself to get 4, a number of bricks 4. 3 is being multiplied by itself to get a number of bricks 9. 4 is being multiplied by itself to get 16 number of bricks. And so what do we do to get the shape, the number of bricks for the fifth shape? It's simply going to 5 times 5, and that is 25. So how many bricks? C says how many bricks are needed for shape 10? Okay, so it's simply going to be 10 times 10. And it's asking how do you know? How do you know? Simply because when you analyze the diagram or the box over here, the chart over here, you'll realize that the number of bricks proceed or are gotten from the shape by itself or the shape squared. Okay, so it's going to be 10 squared, and 10 squared is 10 times 10. Number 9 says write a number between 0 and 100 in each space on the Carroll diagram, and there are a lot of possible answers. Okay, so per this instruction, we can get different answers for each section, but we are just to put a number there, any number at all. We have even numbers, we have not even, we have cube and not cube. Let's start with cube, just because even numbers are very common. So let's list the numbers. We have 1, let's list 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And 10. Okay. So the cube of 1 is simply 1 times 1 times 1. So that is 1. That's the first cube. The cube of 2 is 2 times 2 times 2. And that is 8 times 2. 2 times 2 times 2. That's 4 times 2. That's 8. 3 times 3 times 3. That's 27. 4 times 4 times 4. That's 64. 5 times 5 times 5, that is 125. And so even before we continue, you can see that 125, we reach, if we add that, we go against the instruction given. Per the instruction says it should be between 0 and 100. So these are the cube numbers we have between 0 and 100. That is 1, 8, 27, and 64. Okay. And so amongst these numbers, which ones of them are cube? Okay, which ones of them are cube? Which ones of them are cube? Among these numbers, which one of them are even? Okay, which ones are even? So we have 8 to be even, and we have 64 to be even. So we can put any here, but let's just put the 2. We have 8 or 64. When answering this question, just remember that your instruction says that write a number, so you have to just choose one. Okay. And not a cube number. Between 0 to 100, we have a lot, but still it's going to be even, but it's not a cube number. So I can write 12 or any other number, right? And it's even as well. So it's not cube, but it is even. Okay. And now we are looking for a cube number, but it is not even. And that will be 27 or 1. So I can put 1 or 27 here. And then we are looking for not cube and also not even. That is so many numbers. I can put 13, I can put 35, so many numbers. Okay, good. So yes, a single number can be a perfect square, a perfect cube, and an even number simultaneously. So yes, a single number can be a perfect square, a perfect cube, and an even number simultaneously. The number 64 is a perfect example and it fits all the criteria. It's an even number, it's divisible by 2, that's an even number. It's a perfect square, that's 8 times 8 gives 64. It's a perfect cube, that's 4 times 4 times 4 gives 64. And in order to find this with any number or any even number specifically, this is the formula we use. It's n raised to the power 6, as we have over here. And so any even number raised to the power 6 is automatically a number that is a perfect square, a perfect cube, and an even number at the same time. And so if we take 2, we have 2 raised to the power 6 gives us 64. And from that we get a perfect square, which is 8 times 8, which is 8 to the power 2, and then a perfect cube, 4 to the power 3, that is 4 times 4 times 4, and we have it as a base. That's in the base, which is 2, is an even number. The base 2 is an even number, and so it makes the number 64 automatically an even number. All these three criteria perfectly fit. And the next number that fits all three criteria, that's even, square, and cube number at the same time, is 4096, and that is gotten from 4 raised to the power 6. 4 raised to the power 6. From there, we can get 64 raised to the power 2, and we can get 16 raised to the power 3. And then we know the base, which is 4, is an even number. That is why this number is also an even number. Okay.